Hi, welcome to the 6th trigonometric tutorial. Today's tutorial is titled The Advanced Trigonometry Graph. It is a fairly tricky section of trigonometry, so I do need you to pay careful attention. Also, you need to be very familiar with the first 5 sections on trigonometry. I'd also recommend you go through some of the sections under functions before attempting this tutorial. Reference to this is made in the DVD workbook. Let us begin by attempting a few basic graphs. I want you to have a go at the following. Press pause on your DVD player, and when you return we'll go through it together. The first one we're looking at is sine of 2x. Now I've already drawn the sine of x graph, as you will see it drawn in your workbook. On top of this graph, I'm now going to draw the graph of sine 2x. Now sine of 2x means that at every x value we're going to double it before looking for the sine of that. For example, instead of sine of 90, we're going to say sine of 2 times 90 when x is 90. By the way, this is the x-axis, this is the y-axis. At 90, it's going to be sine of 180. Now sine of 180, looking at our standard sine graph, sine of 180 is equal to 0. Sine of 0 times 2 is 0. 180, 2 times 180 is 360, sine of 360 is 0. 2 times 270 is 540, sine of 540 is 0. Sine of 720 is 0. Sine of negative 180 is 0, 0, 0 and 0. There's a slight problem with this graph. It's only 0. Yeah? No. Think about this angle 45 degrees. 45 times 2 is 90. That means that at 45 we're looking for sine of 2 times 45, or sine of 90, which is equal to 1. At this point here, which is 135 degrees, it's going to be negative 1. So do you see the pattern that's starting to form? Basically what's going to happen is that our graph is now doubled. So our sine graph now in the positive, think about this, in the positive 360 degrees, there's supposed to be one wave. But sine of 2x now means that there's 2 waves. First wave ending there, second wave ending there. So we've doubled the graph. The next graph we're going to look at is y is equal to 2 sine of x. 2 sine of x, now think about this. Sine of 90, when x is equal to 90 degrees, sine of 90 is supposed to be 1. 2 times 1 is equal to 2. Sine of 180 is 0. 2 times 0 is 0. Sine of 270 is negative 1. 2 times negative 1 is negative 2. And 0 again. So what's really happened with saying 2 times sine of x, all we've done is we've doubled both the amplitudes and the troughs of our wave, but our graph still looks pretty much like the sine graph. It's just each amplitude and trough has been doubled. The next graph we're going to be looking at is y is equal to sine of x plus 30 degrees. Now you will remember from the functions tutorial that x plus 30 degrees means that we are moving our graph to the left 30 degrees. Think about this. When x is equal to negative 30 degrees, that is going to be negative 30 plus 30, which is 0. Sine of 0 is 0. When x is equal to 60 degrees, that's going to be sine of 60 plus 30, which is sine of 90. 180 degrees is going to be moved up as well. 150 degrees plus 30 is 180. Sine of 180 is 0. So do you notice that every point on this graph has moved 30 degrees to the left? And that should be over there, but we are going to end it there. That's where it peaks, 30 degrees. Well, actually over there. And the whole graph has just moved 30 degrees to the left. That's sine of x plus 30 degrees. And just carry on up there till 360 from negative 360, because that's our limits, or rather that's our range. X is an element of negative 360 up until positive 360 degrees. I've got the cos of x graph drawn. On top of it, we're going to start with the first graph. Y is equal to cos of a half x. Now cos of a half of x is going to be the opposite of doubling the graph. You will remember sine of 2x meant that we had two waves in place of the one. Cos of a half of x means that we're now going to have half of this graph. When x is equal to 0, 0 times a half is 0. Cos of 0 is 1. When x is equal to 90, that's going to be a half times 90, which is 45, which means that it's going to fall somewhere over here. When x is equal to 180 degrees, it's going to be cos of a half of 180, or cos of 90, which is 0. Sorry, when x is 270, it's going to be cos of a half of 270, which is cos of 135 degrees, which means that that point is going to fall somewhere over there. And when x is equal to 360 degrees, it's going to be cos of a half of 360, which is the same as cos of 180, which is negative 1. The same thing will happen in the negative axis. Basically what's going to happen is that our graph is now going to look something like this. It's going to drop down at 0 at 180 and negative 1 at 360. Notice how different these two graphs are. The standard cos graph versus this graph. It looks very odd. The only reason it looks so odd is because I've limited myself to x having a range of negative 360 degrees all the way up to positive 360 degrees. If it went on further than that, it would still take on the shape, except the x values would be different. That wouldn't be 90, that would be 180, that would be 360, that would be 540, that would be 720.